Good morning, good afternoon, and good evening. This is Mrs. Radel back with another Algebra 2 video. Today we're going to continue our work with writing equations for exponential functions over different compounding times. And so let's start with an example. It says a radioactive substance has a half-life of 15 years. Write an equation that determines the amount, S of x, of 200 grams of this substance that remains after x years. Then find out how much of the substance remains after 30 years. So we haven't talked a lot about half-life yet, but when you think about half-life, we're talking about a factor of 1/2. And so what it really means is that if we start with 200 grams of a substance, we're going to multiply by 1/2 to get 100, and then we're going to multiply by 1/2 to get 50. And then we can multiply by 1/2 just one more time to see the pattern. And we would get 25 grams of the substance. And what it's saying is that the half-life is 15 years. And so it takes 15 years for this halving to occur. So this is 15 years. This is another 15 years. And this is another 15 years. And so let's start to fill out our equation. Our initial value is 200. And we know that our factor is going to be 1/2. And we want x to represent the number of years. So we have 200 times 1/2. And if we just raise it to an x right now, we could start to make a table, right? So if x represents the number of years, this is not the correct answer, but if x represents the number of years, at the first year we would plug in a 1 as an exponent, and we would get 100 grams. And so this is if the half-life was just 1 year, because every year we would multiply by 1/2, and we would go 100, 50, 25. But we know that that's not the truth, right? We know that the half-life is actually 15 years. And so you can think about it as cycles. So 15 years is really one cycle of compounding. 30 years is 2 cycles of compounding, because it's 15 and 15, which is 30. And then at 45 is 3 cycles of compounding, 15 plus 15 plus 15, which is 45 years. And so if you notice what's the same, how I'm finding these cycles every time, is by dividing 15. And so what we can do is we can say, okay, do the initial value times the factor, and then raise it to x divided by the period of which it halves, or whatever the factor is. And so here the half-life is 15 years, so we divide by 15. If the half-life was 30 years, we would do x divided by 30. Or if it was happening every 50 years, we would do x divided by 50. And so that is our equation for this radioactive substance. And now if we want to find how much of this substance remains after 30 years, wherever we see the x, we're just going to put a 30 instead. So we're going to put a 30 here and divide it by 15. And what's nice about this is that we already know the answer. We already know that in these 30 years, we should get to 50. We have 15 years here and 15 years here. And so if we don't get 50 when we type it in our calculator, we know we did something wrong. But if you do 200 times 1/2 raised to the 30 over 15, you will get that it equals 50 grams. And so this is the equation for the radioactive substance that has a half-life of 15 years. So let's do another example, which I had you start thinking about in a few lessons ago, but now we're going to talk about it in more detail. It says a rabbit population doubles every 4 weeks. There are 5 rabbits in the beginning. How many rabbits will there be in 98 days? And so we know we're going to have to do some adjustments to the general equation that we have, because it gives us our factor for every 4 weeks, but our answer needs to be in days. And so let's take from the problem everything that we know. We know that the initial value, because it says at the beginning, is 5. And we know that the factor is 2, because whenever we see the word doubles, we want to think multiply by 2. But we know that this happens every 4 weeks. And we don't care about weeks, we care about x equals the number of days. So let's just get rid of the 4 weeks. 4 weeks is equal to 28 days. So let's just say it doubles every 28 days. And now it's no different than the one that we were just talking about. Instead of it halving every 15 years, it's doubling every 28 days. So now we're going to do a factor of 2. And instead of dividing by 15, we're going to divide by 28. Because that is the period over which the rabbit population doubles just once. And so this is our equation, 5 times 2 raised to the x over 28. And now when we want to find how many rabbits we have after 98 days, we can just plug in. So we're going to do 5 times 2. And wherever we see an x, we want to put 98. Divided by 28. And we'll find that it is approximately 56 rabbits. And so for this Regents question, the answer would be 1, 56 rabbits. Okay? Thank you so much for watching Algebra 2. Go ahead and work on some of those e-Doctrina questions, and I'll see you in the next video. Thank you. Goodbye.